Welcome to Programming Hub. This is Tahsin Akhtar going to explain the amazing facts about floating literal in Python. So what exactly we have to learn in floating literal, I will explain in detail. As you know, number is divided into two parts. First one is integer and second one is floating. The number do not having fractional part is called integer and the number having fractional part is called floating literal. So my agenda is to discuss the detailed information regarding the floating literal. So let's start with the floating literal. Numbers having fractional part is called floating literal. It is also known as real number or real constant. As we know, in mathematics, all the numbers in general is called real number, but in computer, especially in Python, fractional number is called the real number or real constant, and floating number also. Example given here: 2.0 minus 2.25, 12e2, 1.5 e02, 1.25 e plus 2, etc. That means, as per example, in some of the numbers where e used, then definitely this floating literal is not simply represent with fraction, so maybe represent with e. So what exactly e is and what are the forms to represent the floating literal, now I am going to explain. So fractional number means floating number may be in two different forms. First one is fractional form and second one is exponential form. Fractional form, a real constant having decimal point between digits. Example 2.0. So here is decimal point between 2 and 0, minus 2.25. Here also point between minus 2 and 25, etc. So the number which having the decimal point in between the digits is called the fractional form. So in the above example, 2.0 is the fractional for representation of floating literal, but second one is exponential form, means a real constant or floating number with mantissa and exponent. So actually where e term represent exponent, it may be in capital letter or a small letter. As per example 12e2, so where 12 is mantissa part and e2 is exponential part. 1.5 e02, so 1.5 is mantissa part and e02 is exponential part, and many more example available here. Mantissa, it may be either an integer or a proper fractional form. So we are able to represent mantissa in integer form or fractional form, but exponent must be an integer, so you never use fractional form in exponent. Now how to convert fractional form into exponential form and vice versa. So the very first example given here, convert 1.5 into exponential form. So we may write 1.5 mathematically 0.15 into 10 to the power 1. Then exponential form is very easy to write, because into 10 to the power 1 in exponential form represented by e1 or e01, and mantissa means the part given before into symbol is remains as it is. So the exponential form representation of the given number is 0.15 e1. Now second, convert 0.15 e1 into fractional form. This is the vice versa part. So 0.1 even can be written as 0.15 into 10 to the power 1, because for exponent we use into 10 and the number given after exponent used in power. So number given after is 1, that's why 10 to the power 1. If given there 2, then we use 10 to the power 2, minus 1, then 10 to the power minus 1. So if we remove fractional form, that means 0.15 mathematically become 15 by 100. So we represent this equation like 15 by 100 into 10. When we divide and calculate, then it will be 1.5. So we notice exponent may be in capital A or a small a. E01 or E1 means 10 to the power 1. Any value after E will raise power on 10. After E we use may positive or negative value, but never use fractional form. Next, numeric value with comma are not considered as int or float. Python treat them as tuple. So many times mathematically we write 1023 like 1,023. So 1,23 in given example become 1,23 within a small bracket, means it's a type of another data computer will convert in Python. So within a small bracket 1,23 represent tuple. So tuple representation always in a small bracket. So tuple represented in as you know, initially I told the amazing facts regarding floating literal. So I already explained the theoretical ideas. Now practically I want to prove why I called the amazing facts. So let's see many examples. So if you write number like 3.14 and then press enter, then answer will be 3.14, no problem. So if you write answer a number like 314 point, it is mathematically not correct, you know. So after point definitely we need to use 0 or any number, but in Python it is correct. So trailing 0 or zeros not required. So the number after point or 0 after point is trailing zeros, not required. So if you use, then okay. So if you forget and don't use, then no problem, answer will be 314.0. Similarly, if you miss the leading 0 or zeros like point 314.314, so once again there is no problem, answer will be 0.314. So leading 0 or zeros also not required, so no problem. If you use number in exponential form like 3e0, I used here e in a small letter, answer will be 3.0. Why? In exponent, you know, we write 3e0 to like 3 into 10 to the power 0, and any number having power 0 will be 1. So 10 to the power 0 means 1, so 3 into 1 will be 3, and it's a floating representation, that's why 3.0. So you may write e in capital letter. I want to show you here. So it's a 3.0. But if you write number like 3e1, so I used here positive 1, maybe 2, 3. So you calculate, you know how to calculate, I already discussed in the theoretical part. So you get the desired result, but I want to say without any calculation. So as many values given here, the positive value will move zeros to the right, means after point you will put 1 0, but if value given 1, so 3 become 30, value given 2, 3 become 300, likewise. So in that way you write the value. So the answer will be 30.0. If you write 2, then 300.0. But if you use here minus value, -1, then negative value after e moves the decimal part to the left, so answer will be 0.3. Likewise, so one more example I want to put in the exponential form, like 3.14e plus 2, then answer will be, I already told, in that format. So positive is not required here, but you may write, no problem, it will support. So answer will be 314.0. I want to express few more example, and it's also the unique ideas regarding the floating number. If you write a value like 0.0, then answer will be 0.0, no problem, no confusion. But if you write value like 0.000.000, so as many zeros before point and after point, then answer remains 0.0, so answer will be 0.0. If you write value like 001 00.00100, so same part of value I used before point and after point, so answer will be in that case 100.001. so the zero before point and after point zeros, I'm talking about zeros, so there is no impact, it will remove from the result, so answer will be 100.001. One example I want to show on this by using exponent. If you write value like 001e 0010, so answer will be available here, so you calculate, so there is no problem. Few more information I want to by using variable, type function, int constructor and float constructor. So if you store value 3.14 in a variable, and then print a either directly or by using print function, then answer will be 3.14. so I print directly here, but I want to print by using print function also. Print a, output will be 3.14. but if you want to know what type of data type is, then you need to use the type constructor, type. So in type you pass a, the output will be within angular bracket class space within single quotes float angular bracket close. So type function will indicate the nature of data. Few more examples I want to express by using float constructor. So if you type float within bracket 1, then answer will be 1.0. but if you write same thing within single quotes, single quotes indicate either character or a string, then still float constructor will convert this value into float and answer will be 1.0. If you write same value by using point within single quotes, then answer will be 0.10. If you write value like 3 point, no problem, it convert and display answer 3.0. If you write value in exponential form like 1e minus 3, so it will convert and calculate as you learned earlier, so 0.001. If you write value like in negative form minus 0.15e minus 2, then you convert as per the rule, answer will be available here. Few more example I want to put in front of you by using float constructor, like float within bracket nan. Nan means not a number, it's a missing value in Python, so answer will be nan in a small letter. So if you write a small nan, then answer is still nan. If you write infinity, then answer will be inf. So in Python, infinity will be represented by a term inf. So spelling will be wrong, that's why it will generate error here, infiny, infinity. So answer will be inf. If you write code like float within single quotes minus infinity, then answer will be minus inf. If you write minus inf, then answer will be minus inf. If you write plus inf, then answer will be plus inf. So lot many things available in floating literal. So I express some of the examples in front of you. Definitely it is very helpful for you. So go through this video and try to learn and check practically all these things. So thank you for watching this video.